This is part 11 of the Craftsman Emerson 150 drill press rebuild series. If you haven't seen part 10, click the link at the top of the screen. In this video, we will complete the painting and then rewire the motor. Hello everyone, I'm Jeff and welcome to my shop. We got a lot to cover, so let's get to it. Continuing from part 10, we are going to remove the masking from most of this stuff. So all this stuff was painted about an hour ago and we're just pulling off the masking of it. The paint is pretty much dry to the touch, but we're still going to be careful with it because it needs to fully cure for probably 4 or 5 days, especially with the temperatures the way they are in Georgia right now. And we are going to come back and do a final sanding on the milled surfaces for the table and the base after everything is fully cured in about a week or so. So once we've finished removing all the masking on the table, we will move on to the base. So the base is pretty much the same thing as the table. And I always try to remove masking when I paint stuff with spray paint about an hour after I've painted it. In the summertime, I might do it about 30 minutes after I've painted it, but within an hour. And that's because at the edge where the masking is and where the paint meets that masking line, for it to be crisp, you need to do it before the paint is fully cured. And here we are with the motor end frames. So we've got that masked off area for the boss on top, and then we've got the plug that we stuck inside the bore for the bearing. We've got 2 of these, and that completes the motor end frames. So we're now at 1 week past when we painted the head casting, and we're going to mask off the headband area and the nose. And we waited a week so that that paint would fully cure. So as we apply this masking tape, when we go to remove the masking tape, it's not going to peel any of that paint. That paint should be fully cured and we should have no problems with masking it off. And this is why we did that work with the file to kind of define the nose so that we can easily mask the nose area off. And we're just making sure that anytime we do anything like use that X-Acto knife, we're not going to damage the champagne mist base coat. And to be honest, I don't know why they didn't paint these different areas of these head castings and even the tables and the bases in a different color. Why paint them all just one color when they went to the trouble of having this very sculpted Art Deco design to these castings. I think the painting of the nose and the headband, for example, really enhanced the look of it. And maybe it was a cost-saving measure, I'm not sure, but this is what I do with pretty much all of the 100s and 150s that I rebuild. I always paint the nose and the headband area. So once we've got those 2 areas really closely masked, then we're going to have to mask off the larger sections of the head, because we're using spray paint, and spray paint's gonna, as it atomizes coming out of the can, it's going to adhere to anything that's not masked off. So even if you're focusing on just the nose and the headband, if we don't mask off that large section of the head, then you're going to get paint on it. And for that, I'm just going to use some more of that parchment paper or wax paper. And this keeps me from having to basically put painter's tape all over the head casting. And we'll do the same for this side. So I suppose if you were shooting whatever paint you're using with with like an airbrush, for instance, then you probably could get away with not masking as much. But I like to use spray paint because it's cheap, and anytime that you get a scratch or a ding on your part, you can always come back and touch it up. It's also quite durable. Modern spray paints are almost as good as industrial coatings. In fact, there are industrial spray paints that are very robust, chemical resistant and everything. They're a little more expensive, but you can get a lot of different stuff out there, and there's a massive variety of colors to choose from. So we're just masking off that top area, making sure that it is completely covered up. And that's going to probably wrap up all the masking we need to do. Now that we have the head casting masked off, we're going to go ahead and shoot this Rust-Oleum hammered black paint on there. And it is 7215830. And it provides a nice contrast to that champagne mist, in my opinion. So we just need to make sure that we get all that area evenly coated. There are quite a few lips and edges, so you've got to hit this from multiple angles just to make sure you got everything. And then about an hour after we shot this, we'll remove the masking. So I made this wiring diagram, or kind of a wiring diagram, to help you guys out. Basically, that we're going to be rewiring the motor. And what I mean by that is we're going to replace the stator wires and the wiring on the switch assembly and the Klixon and the capacitors as well. The original wiring on all this stuff is really brittle. So we're using a silicone high temp wire, and I'm going with a 14 gauge. And we're basically splicing it as close as we can to the stator and replacing the existing wiring. And I'm going to be using the same color codes as I had in the diagram. Then we're going to mark all of this stuff after we've replaced it. So since we know where all this is going now, we can go ahead and put whatever kind of connector on the end of that wire that we're going to use. So we've got the two wires that are on the bottom of the stator. We're looking at the bottom here. And then you've got three that are coming off of the side. And on the side, you've got a white one, a red one, and a black one. That white might actually be yellow, but we're going to replace it with white. Kind of hard to tell with how old these wires are. Every once in a while I'll get one of these 6962 motors where the wiring is in really good condition. It's still flexible. There's no reason to replace it. But the majority of them, the cloth insulation that's on that wiring has gotten very brittle. And they're stiff. And if you try to bend them, they will break. If you get that break in the wire, it'll short the motor. So obviously we got to be very careful here. We do not want to mess with any of the windings that are on that stator. And most of these motors, the windings are wrapped with a kind of a jute wire or jute twine. For whatever reason, this one didn't have that wrapping on it. Later, I think in the next video, we'll come back and wrap all that winding with jute. And that's when we get closer to motor assembly. So here we have the capacitor, and they don't make these anymore. This is what we refer to as a sardine can capacitor. So if your capacitor is bad on this kind of a motor, you've got three options. One, buy another one of these motors and use the capacitor from it and then sell the rest of that motor off for parts. Two, find somebody that's selling just the capacitor, and they do sell every once in a while on eBay. Or you could reach out to my buddy Frank Lee over on the Garage Journal forum and see if he's got any. Or three, you can get several modern capacitors that are of the same rating when you put them in parallel, and then basically daisy chain those suckers under the motor base. But you're going to have to make a spacer plate of about 1/2 inch, because the modern capacitors that are out there, most of them are round and they're thicker than this sardine can capacitor. I'm not an electrician, so I don't even try to mess with that stuff. But basically we removed the old solder, which I'm sure you saw was really hard to even get to melt. And then we're replacing the wiring in those 2 points with just short little pieces of wire that have got blade connectors on them. And for all this, I think I'm using silicone wire again, but it's 16 gauge instead of 14 gauge this time. The lead wires need to be a little bit more robust on the stator, but the rest of the wiring can be this 16 gauge. And then I'm going to go ahead and apply some of this liquid electrical tape over where those solder joints are. All right, that's a capacitor. Now this is the Klixon thermal protection, overload protection switch, if you will. Sometimes these go bad if you've got a motor that you've rebuilt and it's not even starting up. It could be this switch. So one way to determine if it's the switch is you could jump those two wires, basically bypass the switch, and see if the motor runs. If it does, then on the back side of these Klixons, there's a alphanumeric code, usually in white paint, and you can order these online and just get a replacement. They still make these. But we're just removing the old solder and the old wiring and then putting new wiring and new solder on there. Pretty simple. So I usually, when I'm doing this, I make all these wires longer than they really need to be. And you'll see when we get to the assembly video for the motor, I end up having to cut a couple of them and shorten them. Just because too much wiring inside that end frame has the potential of getting grabbed by the rotor, and I don't want that to happen. So there's the Klixon, done, done, and done. Here we have the on-off switch. So a lot of times I'll just replace this thing, but I'm going to reuse this one. So we just need to get the old solder out of there and the remnants of the wiring. So if you replace this, most of the time you can get it with blade ends, I guess, on blade terminals on the end of the switch there. And then you can just use a blade connector to connect to them. But we're going to leave these the way they are. Just get as much of the old solder as we can out of them. And when we connect these in the assembly video, we're going to solder the new wires in there. So this is the switch assembly for the governor. And it needs to be cleaned up. I was trying to get all this wiring out of it without having to disassemble it, but it's not really working out. I even tried to clean it up with that wire brush, so I just decided, screw it. We're going to disassemble it. Because that last wire right there, it did not really want to come out of there. So this thing is just held together by a pin. I don't even know what you would call that kind of a pin, but it's hollow and it's mushroomed on one end and it's got a head on the other. So once you get it out of there, there's a spring that goes between the two pieces. So once I get this wire out of it, there we go. Then we're going to go clean all the metal on this stuff up with the wire wheel. But we need to open that little hole that the wire needs to run through a little bit more. That's what I'm using that pick for. Without stabbing yourself. That would be good. So here we are with the parts after I ran them through the wire wheel. And we're just reshaping that pin that holds it all together so that we can put it back together. So there's two contact pads, one on the bottom side of that piece I'm holding and one on the piece that's sitting on the board. And those contacts need to be clean. That's what I was cleaning with the sandpaper earlier. But if you take it apart, you can just wire wheel everything and clean them up. So what we're going to do is we're going to attach the wiring first, and then we'll reassemble this whole piece. I think I'm having a brain fart here. And there we go. All right. So this wire, which is going to go from the switch assembly to the capacitor, that's what the C2 stands for. So we'll solder that piece in. And then we went ahead and coated that spring, the spring that goes in the assembly with some super slick stuff. And then we've got the second wire, which is going to connect to the part that's sitting on the board, and we'll solder it in place. All right, so for assembly, well, we'll mark where that's going, but we know it's going to the capacitor. And if you've got that little wiring diagram, which I'm going to put a link to it in the description of the video so you can download it and print it if you need to. It'll tell you where all these wires go. All right, so to assemble this thing, you got to put the spring in first, and then this top part needs to be arranged in a way that it goes under. There's a little, just on the top of the piece that's on the board, there's kind of an overhang piece, and it needs to slide under that. See how it's sitting on top of it now, but it needs to slide under it. And that captures it and keeps it from flying away. There we go. And then we just line up the spring with the holes on those two parts. You might need a punch or a pin to do that. I think I'm trying to remember which side this pin goes in from. Not that it really matters, but and I probably could have replayed the video where we disassembled it, but I think it'll be fine either way. So once we get that pin in there and fully seated, and if it's mushroomed out at all, it doesn't want to go all the way through. Kind of force it. There we go. So now we just need to mushroom that open end. And for that, you just need something that's kind of pointed but is wider than it, and it would be easier to do all this in a vise, but all we're doing is just mushrooming that end enough that the pin's not going to pull back through the switch assembly. And there we go. And that's how it's supposed to operate. So that is going to wrap up this video. I hope you enjoyed it. If you did, please like and subscribe. In the next video, we will remove the masking from the head unit and then assemble the motor. So we are getting really close to completion. As always, I appreciate the support, and I will see you next time.